physics.com. Hope you are doing well. Okay, so today we have, let's see, consider the function h of x equals x plus 2 quantity to the third minus 3x minus 2. Find any local minimum and maximum values. Okay, so this is a max-min problem. So I'll rewrite it just for clarity. Equals x plus 2 cubed minus 3x minus 2. Okay, so first thing I want to do is find the derivative. So the derivative, change colors just because, I can, and electrons are cheap. X plus 2 squared minus 3. Okay, and we're going to then set this equal to 0 to find critical points. So we have 3x plus 2 squared minus 3 equals 0. X plus 2 squared equals 3 times 3. Go to the 3's. Now we have a 1. X plus 2 squared equals 1. X plus 2 equals 1. Or x plus 2 equals negative 1. Because we did the square root. Because negative 1 squared is 1, just like 1 squared is. So we have x equals, let's see here, negative 1, or x equals negative 3. 2 critical points. So let's draw up a table. I enjoy tables. Nothing against chairs, just prefer tables. X, so we have some critical points here. I'm going to draw up negative 3, negative 1. We have an f of x, which f of x is something. We're not particularly concerned at this point. And we know that at negative 3, when we plug that in to the derivative, we get 0. Okay, so now we want to find out if these critical points are max mins or just critical points that don't have max and min. And to do that, there's different ways we can do that. We could test between here and find out it's going up or down. Or, we just look to see if it goes up or down. Or we can take the second derivative, which is the option I'm going to choose. That's actually h prime there. So we'll do h prime prime of x, second derivative. So we'll take the derivative of this will be 6 times x plus 2. And we have that negative 3 goes away. We'll set this equal to 0. Now we're going for concavity. 6 times x plus 2 equals 0. Divide both sides by 6. X plus 2 equals 0. And this tells us that x equals negative 2. Let's get another color here. I do enjoy my colors. We have negative 2. Comes down. Look at our table. And we know that there is a change in concavity at this point. An inflection point, if you will. So now we want to find out the concavity of these points, of these regions. So I'm going to do h double prime of negative 3. So h double prime of negative 3. We get, what do we get? 6 times negative 3 plus 2, which is negative 1 times 6, which is negative 6, which is less than 0. So this concavity is like this. It's not really a frowny face. That's it's just my way of demonstrating the concavity in that region. So it is concave down. Now let's do h double prime of 0. I like to use 0 just because it's easy to do math with. We could have chosen anything that's greater than negative 2. So we have 0 plus 2, 2 times, which is 2. 2 times 6 is 12. 12 is greater than 0. And so we're going to be concave up. All right. And so now from this point, we know that our graph is going to follow a concavity where it comes up and is concave up here and then concave down here. So that what that tells us then is f of negative 3 will be a maximum because it'll be right there. And then negative 1 will be a minimum. And you visualize it right there. Because on this, so we know we have a maximum or minimum at negative 1 because our concavity is up. We know that it's going to be the minimum. So f of negative 1 will be a min. And there you go. That is the max and min. Hope it helps. See you next time.